Welcome to the wonderful world of elasticity. It's me, your host, Selena Lindahl. All right, so let's take this in pieces. In this piece, we'll talk about elasticity, specifically the price elasticity of demand, which generally just measures how sensitive consumers are to prices. We'll talk about how we calculate it, why we use the midpoint formula, and then we'll talk about how the idea of elasticity relates to the slope of the demand curve. So, what's going on with price elasticity of demand? Well, the law of demand states that as price rises, generally the quantity demanded falls, and vice versa. But by how much? So there's a negative or inverse relationship between price and quantity demanded, even for things like ambulance rides. Exactly how much? That's the question in front of us. So you can indeed visualize this, if you like, as a rubber band that has more or less elasticity. And like a rubber band, when you pull it in one direction and release, it shoots off in the other direction. That's kind of what's going on with price and quantity demanded if you think about the demand curve. Pull up on the price a little bit and quantity demanded drops. How much does it drop? If it's an elastic demand, it drops a lot. But if people don't respond much, not so elastic. So an old worn out rubber band or even just a piece of rope, that's kind of inelastic, whereas a new fresh rubber band has a strong response when you pull in one direction. All right, so let's look at the demand curve for ambulance rides. Two different prices, two different quantity demandeds. So when price rises from 200 to 210, we demand 9.9 million instead of 10 million. Do we say this people are being sensitive or not? Well, I mean, you think about the good in or service in question, of course, people are going to be less sensitive to prices about on ambulance rides than other prices, but still, there's a drop, right? But we want to be able to quantify it. So let's take an even more generic demand curve. Let's look at what happens when price rises, we drop, right? So would you call this demand curve very sensitive? Are people on this demand curve very sensitive? Well, relatively speaking, check this demand curve out. On this demand curve, the same two prices yield a much larger change in quantity. So you can get the feeling that the elasticity is somehow related to the slope. Just be careful, it's not exactly the same as the slope, but the flatter curves are generally more sensitive to price or more elastic in price, and the steeper curves are generally speaking people are less sensitive to price. So let's talk about how to calculate it. We're going to want to make it as simple as possible so we can compare apples to apples and not get confused by units, etc. So let's be formal here. The price elasticity of demand is the percentage change in quantity demanded divided by the percentage change in price, or the form of the equation. So if the price of oil increases by 10% and the quantity demanded falls by 5%, we could say that the price elasticity of demand in this particular case is a negative 0.5. And here's a quick reflection question. Why the negative number? If you remember what the two things that are being measured here, percentage change in price and percentage change in quantity demanded, they move in opposite directions always, hence the negative sign. So since there's normally a negative sign, we actually kind of ignore it. We don't hassle too much about that. And we indeed, in economics, for the price elasticity of demand, we usually take the absolute value. And are you ready for some more exciting calculation news? I won't keep you waiting. The percentage change calculation that we normally do, the most traditional one that we've all learned, is different than the one we do here. Here's why. So, bear with me. If I go from 100 to 200 pounds, I have gained 100% of my body weight. If I go from 200 to 100, I have lost 50%. You get the problem? The number varies greatly depending on which direction you go. So because the typical calculation that we do for percentage change is biased toward the base point, we want to unbias it and take the midpoint instead. So from now on, we assume we'll be using the midpoint formula for percentage changes. Here's what that looks like. For any percent change in any variable, you just take that change, and instead of dividing it by the base point or its first value, you divide it by the midpoint or the average of the two values. So going from 100 to 200, now you divide 100 by the midpoint of the two, which is 150. Notice that if you go from 200 to 100 the other direction, you'll also get 50%, negative 50%, but 50%, right? So it doesn't depend on the direction. This calculation, the midpoint method, does not depend on the direction, and that's why we like it. So if you ever need to have it all spelled out, the average or the midpoint, you just take the two numbers, add them together, and divide by 2 to get the midpoint. So here's an example. The initial price of $10, the quantity demanded is 100. When the price rises to $20, the quantity demanded is 90. Here's how you would set up the problem. And one mistake I see a lot of students make is to do the harder math work, which is this little calculations, making sure you get it all set up, only to lose it all in the end because they accidentally put 66% on top and 10.5%, negative 10.5% on the bottom. The problem there is we're looking, always elasticity looks at percent change in quantity divided by percent change in price, right? You're looking to see how much quantity changes relative to price. So price has to go on the bottom, quantity on top. Don't accidentally flip them over. So here we go, negative 0.15. And as we know, it's always going to be negative, so you may just be asked for the absolute value of it. Here's a practice question. I'll read it and then you can pause it and work the problem. If the price of a sushi roll drops from $8 to $4 and sales rise from 20 to 40, what is the absolute value of the price elasticity of demand? Okay, pause. And you have worked out the problem. Let's see if you got the same answer I did. 1. So, using the midpoint formula, right? Good job, and that is it for the first elasticity video.